Integrating Apache Kafka with machine learning pipelines. The integration of Apache Kafka with machine learning pipelines represents a powerful synergy between two transformative technologies, each playing a pivotal role in the modern data-driven landscape. Apache Kafka, a distributed streaming platform, has gained widespread recognition for its ability to handle real-time data streams at scale, ensuring reliable and efficient communication between disparate systems. Data ingestion and integration. Data ingestion involves the process of collecting, importing, and organizing data from diverse origins into Kafka topics. Integration, on the other hand, delves into the orchestration of data movement between Kafka and machine learning components. Event-driven architecture for machine learning. The event-driven architecture enables a decoupled and modularized system, where components within the machine learning pipeline react autonomously to specific events. The adoption of an event-driven architecture, powered by Apache Kafka, propels machine learning pipelines into a realm of responsiveness and adaptability that aligns with the dynamic nature of contemporary data ecosystems. Real-time data processing in machine learning workflows. Real-time data processing stands as a cornerstone in the integration of Apache Kafka with machine learning workflows, revolutionizing the traditional paradigm of batch processing. Ensuring data quality and consistency. Ensuring data quality encompasses several key facets, beginning with the validation and cleansing of incoming data streams. Consistency, on the other hand, involves harmonizing data formats, schemas, and semantics across diverse sources and destinations. Monitoring and management of integrated systems. Monitoring and management strategy is imperative for organizations navigating the intricacies of integrating Apache Kafka with machine learning pipelines. Security and data privacy in integrated systems. Fundamental to the security framework of integrated systems is the implementation of stringent access controls and authentication mechanisms. Authorization mechanisms play an equally vital role, defining and enforcing fine-grained permissions to ensure that users and components have access only to the data and functionalities essential to their specific roles. Future trends and innovations. Decentralized machine learning architectures. Future trends indicate a shift towards decentralized machine learning architectures within integrated systems. Integration with advanced analytics. The future holds a convergence of Apache Kafka with advanced analytics techniques, including artificial intelligence, AI, and deep learning. Enhanced security and privacy measures. Future innovations in the integration of Apache Kafka and machine learning pipelines will be closely intertwined with heightened security and privacy measures. Conclusion. In conclusion, the integration of Apache Kafka with machine learning pipelines represents a transformative synergy that propels data processing and analytics into a new era. The journey from data ingestion and integration to event-driven architectures and real-time data processing underscores the dynamic nature of this integration. The integration of Apache Kafka with machine learning pipelines signifies more than just a technological collaboration. It represents a strategic imperative for organizations seeking to thrive in a data-driven world.